Hey everyone, welcome back to my YouTube channel. In this video, I'm going to share with you about minimal version selection algorithm. So this is a algorithm used by Go language to manage which versions that it should select when we try to build our binaries or try to download or upgrade the dependencies, right? Which is it will try to read from our GoMods files and then do the algorithm starting from there. So if you want to see the implementations, I can give you the source link so you can read about the code implementations. So let's go to the drawing board over here. So the algorithm will try to get all the dependencies required by our applications and make a dependencies graph like this. So here we have 7 modules for our applications, and each modules will have versions from v1.1 to v1.2. So this is the first version and this is the last versions. And then this versioning should follow semantic versionings. Alright, so if you go to the documentations, it has an assumptions that every module should follow import compatibility rules, and one of the rules is should follow the semantic versioning. And this graph able to be drawn like this because it can fetch this information from the Go proxy, the module mirrors that we have discussed in the previous video on how Go can fetch the requirements, right? So let's begin with this build over here. So what happens if the application build the binaries? What happens if we run the gomod tidy command? So it will start selecting our requirements versions first, b1.2, right? b1.2, get it, put it in the list, and then next it select d1.3. So it will not try to select d1.4 even though d1.4 is the latest versions, because the latest version doesn't always mean the greatest versions for our applications. So it will try to honor that d1.3, then it has e1.2 as the dependency. So this is our direct dependencies, and these two are our indirect dependencies. Now continue, it will select c1.2, and c1.2 requires d1.4, and d1.4 requires e1.2. Now we have two versions of D in the list. So for this case, the algorithm will choose the minimum required versions, which is D1.4. Right? It will choose this because C1.2 requires minimum D1.4. So there is a social requirements or social contract that the maintainer of modules D required to have backward compatibility for these major version ones. It means that if B1.2 use D1.4, it will not break. Alright, so that's the first case. So the next section is what happened if we decided to upgrade all the dependencies to latest versions, we can do that using the go get min u flag. So basically, essentially, it will try to change the directions, the requirements to the latest versions, right? So now every B modules in this graph will use D1.4 and every D will use E1.3, right? And then now it will try to build the applications. So from here, the application will choose the latest version, which is B1.2 and then C1.3, right? There. And then it will use F1.1 and G1.1. And then it will choose D1.4 and then upgrade to E1.3. Right, that's what going to happen. And then these changes, by the way, will be saved in these applications go sum only. Okay, so it will not change in this go sums files, right? It will change in this go sums file only. So in this section, I'm going to show you how if we want to upgrade one modules only. Let's say I decided to upgrade to C1.3, right? This one, right? So it will create a new arrow to this shoot like that, right? Shoot like that. And then it will put these on the list, right? And then because C1.3 requires F1.1 and G1.1, you put this to the list also, like that. So now we have the same version for C for major version 1. The same rules applies. It will try to use the minimum required versions, which in this case is C1.3. So therefore, this will be ignored, right? It choose this one. But right now, we are not using C1.2. So how about D1.4? So the algorithm will not downgrade this to D1.3 again because it doesn't store your log history. So it will remain use D1.4. So this is what happens if we choose to upgrade one versions only. So the last sections is what happened if we decided to downgrade a versions, right? Let's say we found a bug in D1.4 and the bug is happened there because it introduced in version D1.3, right? Therefore, we have to downgrade to D1.2. Okay, so let's do this again. We decided to downgrade D1.2, so let's mark this and this, right? So the algorithm will remove 1.4 and 1.3 from the equations and then select D1.2. Therefore, B1.2, which requires a minimum version of D1.3, cannot be used, right? Because D1.3 will be removed. Therefore, it will downgrade B to B1.1. Right? This is now become the minimum requirement versions for this state. So it will ignore this. So now it use B1.1 and then use D1.2 and then use E1.2. So the E is not required to be downgraded, right? So it will remain use E1.2. So C is using D1.4, but D1.4 is removed. Therefore, it has to choose C1.1 and remove C1.2. I mean by remove is downgrading, alright? Alright, so this is what happens if we choose to downgrade the dependencies. That's it that I want to share with you. Again, it is up to your decisions. This is an engineering decisions whether you want to use always the latest versions or the current versions, right? This is up to you. But what you have to make sure is to have always a good test in your application so that if you change the versions of your dependencies, you can make sure that your applications will not broken, right? So I hope you enjoy the content. I'll see you around in the next video. Keep learning and stay healthy. Bye bye.